So maybe 2 videos is even being optimistic if I keep going at this pace. We'll see. So I cut off in the last one. Potential energy has an equation. Let's see. Equation for potential energy is PE equals mgh. In class, I'll show you how to convert that into a cheater triangle based on G being a constant. So the reason we're able to do this, even though it looks a little bit scary with all the letters, is that G is a constant. M stands for mass. We're always going to, we're not going to mess around with units as much as we did in the motion unit. I feel like I use units a little bit too much in these things. Mass was always going to stay kilograms for energy here. G, I talked about G being a constant. We know the value for G here on Earth, and we're always going to be here on Earth for this unit. We're not going to throw you at Mars or Moon unless we maybe have a challenge question. Then we'll make it very obvious what G is. But here on Earth, 9.8 meters per second squared. We'll use that for all of our equations unless some other specification happens. H will be measured in meters, and potential energy stands for energy measured in joules. Potential energy versus kinetic energy. Kinetic energy is the energy of motion. Energy of motion. So in order to have kinetic energy, you have to be in motion. If you're at zero, if you're at a velocity of zero, constant velocity of zero, you can't have kinetic energy because you're not in motion. I'll show you that in the equation version a little bit. But that's the big key. Unless you're all the way to the center of the Earth, you always have some potential energy due to gravity. But you cannot have kinetic energy unless you are actively in motion. So then we're back to it depends on the mass and it depends on its speed or velocity. To calculate kinetic energy, we get another equation. This one looks even scarier. It's not as bad as it looks. We'll just find that out in class. Kinetic energy equals 1/2 mv squared. How I like to think about that is that, and once again, it's just constants. 1/2 is a constant. I like to think of it as mass being less important. Mass is 1/2, and velocity gets squared, gets made larger. So mass has less importance in the kinetic energy equation than the velocity. But either way you want to think about it, mass is still measured in kilograms. Velocity is measured in meters per second. I get that my face is cutting that off a little bit there. And kinetic energy is still measured in joules because it's just a type of energy. And we'll get practice with that in class. BP2. So we'll see. Once again, I'm kind of envisioning this will go on to a third video by just a little bit. BP2 is about conservation of energy. Basically, I don't know if you've heard it before, but energy cannot be created or destroyed. Matter cannot be created or destroyed. Now, there's a little bit, if you get to really high physics, between transferring between matter and energy. That's a different conversation. But stuff cannot be created or destroyed. It can only be transferred. So you can convert energy from one form to another. Favorite example of that, lighting a match. Some of you, it's always kind of funny when we have students light a match in class. Some of you don't even know how to do it. But it's kind of funny. When you strike a match, you're actually using chemical energy from inside your body to create motion, kinetic energy. Then that motion creates friction on the side of the box, thermal energy, which ignites the chemical energy stored on the tip of the match, which then becomes thermal energy, gives off heat and light. Electromagnetic energy goes out into the room, joins the air energy and everything, and just keeps moving around. So even the simple lighting of a match has a lot of conversions of energy, a lot of different stuff going on with the simple lighting of a match. Another example, we do the rock example a lot since rocks aren't propelled by anything. So we use the rock example a lot on the top of a cliff, at the bottom of the cliff, rolling down a hill. If you had a rock at the top of a cliff, it has potential. You kick it off the side, it starts falling. That potential becomes kinetic, and then it has less potential. But unless it goes all the way to the center of the Earth, that doesn't ever hit zero potential. We can also diagram this, and I guess that'll happen in my third and final video. Sometimes my eyes are too big for, or my optimism doesn't carry through to the timing of this. I'll get you in the last video with our last couple topics.